This is Advanced Math, Unit 7, Lesson 2, Notes. That's 7.2 Notes. The title is Right Triangle Word Problems. You should have received this handout in class. If not, you can print it from the website or just hand write it out. You will also need a scientific calculator. It is titled Right Triangle Word Problems. Number 1. From a point 50 feet in front of a building, the angles of elevation to the base of a sign and the top of the sign are 45 degrees and 47.75 degrees. Find the height of the sign. All right, so let's draw a picture. So we have this building, and there is a sign on top of the building. And here is the ground. Here is the sign. Okay. Now, from a point 50 feet in front of the building, so let's say here's the point, and this is 50 feet from that point to the base of the building. The angles of elevation to the base of the sign and the top of the sign are 45 degrees and 47.75 degrees. Okay, so from here to the base of the sign is 45. So I'm going to put this in pink, 45 degrees. And then to the top of the sign, from that same point to the top of the sign is 47.75, which makes sense because you're having to look up even higher from here to here, so the angle should be bigger. So this bigger angle here is 47.75. And then the question is, find the height of the sign. So we're looking for just this height right here. Now you can see if I were to cover this bottom triangle, that's not a right triangle, and right now we're working with right triangle word. Right now I don't have enough tools to find the height using that smaller triangle. So I'm going to use the fact that we have two right triangles right in here. We have a small one and we have a big one, and that's what we're going to use. Okay, so first thing I'm going to do is redraw this pink triangle right here. And then I'm going to redraw the purple triangle. And I am going to draw the purple one first, and there is a reason, and I will show you in just a second, but for now I'm going to draw the purple one first. Get this in. And the purple one, this is 50. We do not know the height, so I'm going to call it X. And for the big triangle, this is 47.75 degrees. Okay, and then the smaller triangle, still 50. I'm going to call this Y, and this is 45 degrees. Okay, I'm hoping you can recognize that this little green height here, if I can find the height of the big triangle and the height of the small triangle, what would I do with the two? I would subtract the height of the big, take away the height of the small, will give me the height of the sign, which is what I'm looking for. Find the height of the sign. So we're going to take the height, find the height of the big triangle, subtract the height of the small triangle, and that's going to give us the height of the sign. Okay, so looking here, I can't use Pythagorean's theorem, which forces me to use SOHCAHTOA. I know this angle. I'm looking for its opposite. I know the adjacent, that is tangent. Tangent of 47.75 equals X over 50. Multiply both sides by 50. plug it in your calculator, 50 times tangent of that angle. And let's always round to 3 decimal places. Okay, that didn't type in, and it's not working for me. Okay, I'm going to find a calculator that works. You can plug it in. It should come out to be x equals 55.046. And go ahead and set the next one up as well, also using SOHCAHTOA. Okay, 50 times tangent of 47.75, 55.046 when you round to the nearest 3 decimal places, nearest thousandths. Okay, next one, we're also going to use tangent. Tangent of 45 equals opposite, which is y, over adjacent, which is 50. Multiply both sides by 50, plug that in your calculator, 50 times tan of 45. 50 times tan of 45. And it comes out to be 50, which makes sense because tan of 45 is 1 and 1 times 50 is 50. So this comes out to be 50, and then you subtract the 2. 55.046, take away 50, equals 5.046 feet. The height of the sign is 5.046 feet. Okay, moving on. Bearings. This is something you will need to know how to work with for this unit. Bearings are an angle made with blank and blank lines. They are made with north and south lines. What that means is people like flying aircrafts or in a boat use bearings, or people out in the wilderness use bearings. When you don't have streets to say, oh, you go down 2 miles and make a right on Blackstone, that kind of stuff. You don't have that out in the wilderness or in a plane or in a ship. You use bearings. So you will see something like this. This is what it looks like. North, 30 degrees east. Okay, you will always start with the north or south line. That's always going to be your first, north or south, and your second's always going to be west or east. So you always position yourself north or south first. North is facing up, so I'm going to put a little dot here, and there's my north line. Okay, so picture this little dot is where it's going to swing from, 30 degrees east. Would I swing to the right or to the left for east? East is to the right, so how far do I swing to the right? 30 degrees. So you approximate going 30 degrees this way and make a line. And that's north, 30 degrees east. All right, let's try another one. Let's try south, 47 degrees west. Okay, so we have our little dot. That's where we're going to swing from. I put up at the top because I want my line, excuse me, to be pointing south. So, and then this is where I'm going to swing from. Which way am I going to swing, right or left? For west, I'm going to swing to the left, and I'm going to swing 47 degrees. So there's south, 47 degrees west. Let's try one more. North, 17 degrees west. Again, the first the first line is always going to be north or south. The second will always be west or east. You're never going to go north, north, or north, south. It's north or south first, and then west or east second. All right, my line pointing north will be pointing upward because that's the way north points. That's the line. That dot here is where I'm going to swing from. Am I going to swing right or left for west? West is to the left. North, south, west, east, just as a reminder if you have forgotten. West is to the left, and I'm going to swing 17 degrees, which isn't very much. That's what it would look like. North, south, north, and then east, west, west. Okay, let's try our last example. Number 2, boat A leaves dock going north. Boat B leaves dock going north 37 degrees east at 27 miles per hour. After 3 hours, boat A is exactly due west of boat B. How far apart are they? Okay, so let's say this is our docking station. Boat A leaves the dock heading north. This is north. So it's going straight north, straight vertically up, and this is boat A. After 3 hours, that's where it's at. Boat B leaves the same dock going north 37 degrees east. Okay, I already have my north line in place, so I don't have to redraw it. From north, I'm going to scooch over 37 degrees east. This way is east, 37 degrees, and this is going to represent the path for boat B. 37 degrees goes in there because that's north, 37 degrees east. Okay, after 3 hours, boat A is exactly due west of boat B. So that means there is a horizontal line here. Boat A is exactly due west of boat B. North, south, west, east. Boat A is exactly due west of boat B. How far apart are they? Okay, so what we're looking for is this length right here. And how do we find it? Okay, so since this is a north line, since this is exactly a horizontal line, this is a right triangle. Can you see we're going to use our right triangle trig? I'm looking for the length of a side, and I don't know any other sides. So what do I do? Well, first off, there's information I have not used yet. Boat B is traveling at a rate of 27 miles per hour, and they've traveled for 3 hours. Distance equals rate times time. So the mistake kids make is they put the 27 here. No, the 27 is a rate, not a distance. Distance equals 27 times 3. That's what you would multiply. So after 3 hours, boat B has traveled 81 miles. So 81 goes here. All right, now I do not have enough for Pythagorean's theorem because I do not know that third side. So I'm going to use SOHCAHTOA. So let's check. I have this angle. I'm looking for the opposite side, and I know the hypotenuse. So what am I going to use? I'm going to use sine. Sine of 37 degrees equals opposite, which is x, over hypotenuse, which is 81. And once I solve that, I will have found the length or the distance between boat A and boat B. Multiply both sides by 81. X equals, and plug it in. 81 times sine of 37. 3 decimal places, 48.747. That is it for this lesson.